26 December 2004. A magnitude 9.1 earthquake off the coast of Sumatra triggered one of the deadliest tsunamis in recorded history. Waves up to 30 meters high. 230,000 people killed across 14 countries. In Cuddalore, India, 2 villages were hit by the same waves on the same morning. One village lost 2 people. A village 500 meters away lost 6,000. Same event, same waves, 500 meters apart. What made the difference? The answer is the subject of this video. This video is for you if you are a Sec 1 geography student and you know that mangroves are valuable. But when an exam question asks you to explain why, you find yourself writing things that are too vague to earn marks. You might know the word coastal protection, but not the mechanism. You might know Sungei Buloh is a case study, but not what statistic to use and when. You might lose marks on evaluation questions because you list strengths and weaknesses without making a judgment. Today we fix all of that. By the end, you will have 4 clear value explanations, 3 case studies with named statistics, and an evaluation structure that works for any management question. Here is today's roadmap. We start with the 4 values of mangroves, and for each one, we go straight to the mechanism. Then we'll go through 3 case studies, the 2004 Indian Ocean tsunami, Sungei Buloh in Singapore, and the Sundarbans in Bangladesh and India. After the values, we look at the threats, why mangroves are disappearing, and then management strategies, and how to evaluate them. The whole video is about 17 minutes. Have a notebook ready? The case study statistics are the ones to write down. Let's go. Chapter 1. The 4 values of mangroves. I want to start with a simple point that students often overlook. Mangroves are not just interesting ecosystems, they actively do things. They protect lives. They support ecosystems that other species depend on. They feed millions of people. And they slow climate change. The 4 values we will cover are coastal protection, biodiversity and habitat, fisheries support, and carbon storage, which scientists call blue carbon. These 4 values are the reason mangrove conservation matters. And they are the reason why losing mangroves has consequences that last for generations. Value 1. Coastal protection. Mangroves act as a natural buffer. They reduce the energy of waves, storm surges, and tsunamis before those waves reach inhabited land. Here is the mechanism, and this is the part you need to be able to explain in the exam. When a wave moves toward the coast, it normally travels freely, nothing in its way. But when it reaches a mangrove belt, it has to push through a dense network of prop roots, trunks, and branches. That dense structure creates enormous physical resistance. The wave has to expend energy forcing its way through the vegetation instead of rushing freely inland. The result, wave height is reduced. Flow velocity is reduced. The water arrives slower, with less force. And the mangroves trap sediment and debris carried by the water, reducing abrasive damage. Now let's put numbers on that. Look at the infographic on screen. Each 100 meters of mangrove belt reduces wave height by 50 to 70%. So if a wave is 3 meters high when it reaches the mangrove, after 100 meters of mangrove, it is between 0.9 and 1.5 meters. After 500 meters, it can be reduced by up to 90% to about 0.3 meters. The exam statistic you need is this. Each 100 meters of mangrove belt reduces wave height by 50 to 70%. Write that down. That is the statistic that turns a vague answer into a strong answer. Not just mangroves reduce waves, each 100 meters of mangrove belt reduces wave height by 50 to 70%. Now the case study that proved this in the most dramatic way possible, the 2004 Indian Ocean tsunami. 26 December 2004. The earthquake off Sumatra sent waves across the Indian Ocean to Sri Lanka, India, Thailand, Indonesia, and beyond. Over 2,000 people died. After the tsunami, researchers went to the affected coastlines and mapped the damage. They found a striking pattern. Communities that were located behind intact mangrove belts suffered significantly fewer deaths and significantly less structural damage than communities in equally exposed locations where the mangroves had been cleared. The data was consistent across multiple countries. In Sri Lanka's Hambantota district, areas with dense mangroves averaged 2 deaths per kilometer of coastline. Areas without mangroves averaged 6 deaths per kilometer. The same wave, the same coastline, very different outcomes. Here is the part of the 2004 story that is the hardest to hear. Many of the most severely damaged coastlines had previously cleared their mangroves specifically to build shrimp aquaculture farms. The very places where thousands of people died had, years earlier, removed the natural protection that might have saved them to build shrimp ponds. Before we move on, there is one thing I need you to note very carefully for the exam. Mangroves reduce wave energy. They do not eliminate tsunami risk. They cannot stop the largest waves. Their protection is most significant for smaller waves and storm surges, and for communities behind a wide, intact mangrove belt. Do not say mangroves stop tsunamis. Say they reduce wave height and flow velocity. That is the accurate statement, and it is also the one that earns full marks. Value 2. Biodiversity and Habitat. Mangroves support an extraordinary variety of species, including many that are found nowhere else, and many that use the mangrove at a critical stage of their life cycle. Here is the mechanism. Prop roots create layered microhabitats. Above the waterline, birds, reptiles, and insects use the roots and branches for nesting and feeding. At the waterline, crabs, mud skippers, and intertidal fish exploit the zone between water and air. Below the waterline, juvenile fish and shellfish shelter among the roots, protected from predators. That's not all. Fallen mangrove leaves decompose into organic detritus. That detritus feeds invertebrates. Invertebrates attract juvenile fish. Juvenile fish attract larger predators. The entire food web of the surrounding marine environment is connected to the mangrove's productivity. The intertidal location is also key. Mangroves bridge the marine and terrestrial ecosystems, which means species from both worlds can exploit this habitat. Singapore's case study for mangrove biodiversity is Sungei Buloh Wetland Reserve. Sungei Buloh is located in the northwest of Singapore, near Kranji. It covers approximately 202 hectares of mangrove forest, mudflats, and freshwater ponds. 2 international designations you need to know. A Ramsar wetland of international importance, designated in 2002. That means the United Nations recognizes it as globally significant for wetland conservation. And an ASEAN Heritage Park, designated in 2003, recognizing it as outstanding natural heritage within Southeast Asia. The biodiversity statistics, over 500 species of animals have been recorded in the reserve. And each year, from September to March, more than 90 species of migratory birds use Sungei Buloh as a critical stopover point on the East Asian-Australasian flyway. That is one of the world's busiest bird migration routes, stretching from Siberia and Alaska all the way to Australia. Without Sungei Buloh, those birds would have no suitable resting and feeding habitat in Singapore during their migration. Now let's look at how Singapore manages Sungei Buloh, because you will almost certainly need this for evaluation questions. The National Parks Board, NParks, manages the reserve through several strategies. Legal protection: the reserve is designated under the Parks and Trees Act. No development is permitted within the reserve boundary. This is the strongest and most immediate protection. Replanting: NParks actively plants mangrove propagules in sections that have been degraded and monitors survival rates annually. Public access management: boardwalks and designated trails direct visitors away from sensitive root zones and mudflats, reducing physical damage to the habitat. Research and monitoring: regular biodiversity surveys, water quality checks, and bird ringing programs are conducted in collaboration with the Nature Society of Singapore. And there is a buffer zone policy. Development restrictions apply in areas surrounding the reserve to reduce runoff, noise, and light pollution reaching the mangroves. Here is the evaluation. The strengths are clear: strong legal protection, active management, and international recognition. The limitation is equally important. The reserve is only 202 hectares. Singapore has lost over 95% of its original mangrove cover to land reclamation. What remains is protected, but most of what was there is already gone. Value 3. Fisheries Support. Mangroves serve as critical nursery grounds for juvenile fish and shellfish, and these are species that millions of people's food security and livelihoods depend on. The mechanism works like this. Fallen mangrove leaves decompose into organic detritus. Detritus is a food source for small invertebrates. Those invertebrates attract juvenile fish, which take shelter among the dense prop roots, protected from predators. The prop roots are like a cage that predators cannot easily navigate. While sheltering, juvenile fish grow. Once they reach maturity, they move to open water, to coral reefs, estuaries, and offshore fishing grounds. But their survival to that point depended entirely on the mangrove nursery. Here is the key statistic. An estimated 75 to 80% of all tropical fish species spend part of their life cycle in mangrove or estuarine habitats. When mangroves are cleared, the nursery is gone. Without the nursery, fish populations decline. Where that has happened, nearby reef and offshore fish catches have fallen significantly, directly harming the food supply and incomes of coastal fishing communities. Value 4. Carbon storage, or blue carbon. Blue carbon refers to carbon stored in coastal and marine ecosystems, specifically mangroves, seagrasses, and salt marshes. Here is how mangroves store carbon. The trees absorb carbon dioxide from the atmosphere through photosynthesis. That carbon is stored in the wood, the roots, and the leaves. When the trees eventually die and their leaves fall, the organic matter enters the soil beneath them. And here is the crucial part. The soil beneath a mangrove is waterlogged and anaerobic. Remember that from V15. In those conditions, decomposition happens extremely slowly. The organic matter, the carbon, gets locked in the soil for centuries. The result, mangroves store 3 to 5 times more carbon per hectare than tropical rainforests, not because the trees themselves are larger, they're not, but because the soil beneath them holds ancient carbon stocks that simply don't exist in well-drained forest soils. What happens when mangroves are cleared? Both the above-ground carbon and the ancient soil carbon are released. The wood and leaves are burned or left to decay, releasing carbon dioxide immediately. When the waterlogged soil is drained or disturbed, centuries of locked-in organic carbon begins to decompose rapidly. Globally, mangrove loss is estimated to release between 0.02 and 0.02 and 0.02 billion tons of carbon per year. That is a significant contribution to climate change from a relatively small total area of forest. The loss of mangrove blue carbon also creates a double problem. You lose the carbon sink, the forest that was absorbing COSSS, and you simultaneously release the stored carbon that it had accumulated over centuries. Pause the video now. Draw a table with 4 rows, 1 per value, and 3 columns, what it is, the mechanism, and 1 statistic. Complete the table for all 4 values. Then try to write a full answer to this question without looking at your notes. Explain 2 reasons why mangroves are valuable. 4 marks. Write your answer using this structure: value, mechanism, evidence. Pause now. When you are ready, unpause for the model answers. Welcome back. Here are the model answers. Coastal protection. The dense prop roots, trunks, and branches resist water flow, absorbing wave energy as it passes through. Each 100 meters of mangrove belt reduces wave height by 50 to 70%. Biodiversity and habitat. Prop roots create layered microhabitats above and below the waterline. Leaf litter feeds invertebrates that sustain fish and birds. Sungei Buloh supports over 500 animal species and more than 90 migratory bird species per year. Fisheries Support. Fallen leaves decompose to detritus, which feeds invertebrates, juvenile fish shelter among prop roots from predators. An estimated 75 to 80% of tropical fish species use mangrove habitats during their life cycle. Blue carbon. Trees absorb COSE. Waterlogged anaerobic soil locks organic carbon for centuries. Mangroves store 3 to 5 times more carbon per hectare than tropical rainforests. Check your own answers. Did you include the mechanism, the process? And did you include a statistic? Both are needed for full marks. Chapter 2. The Sundarbans. The Sundarbans is the world's largest mangrove forest, and it is perhaps the most important case study in this entire topic because it demonstrates all 4 values of mangroves in one place, and it also faces nearly every threat we are about to discuss. Where is it? where are the Ganges, Brahmaputra, and Meghna rivers meet the Bay of Bengal, in the delta shared by Bangladesh and West Bengal, India. The Sundarbans covers approximately 10,000 square kilometers. Bangladesh has about 60%, India has about 40%. The scale of the Sundarbans is remarkable. For coastal protection, the Sundarbans acts as a natural buffer protecting the densely populated coastal lowlands of Bangladesh and West Bengal from cyclones and storm surges. It is estimated to reduce storm surge heights by up to 2 meters. For biodiversity, the Sundarbans supports approximately 400 Bengal tigers, the world's largest tiger population living in any mangrove forest. It also has Irrawaddy dolphins, saltwater crocodiles, the Ganges river shark, and around 250 species of birds. For fisheries, an estimated 3 to 4 million people depend on the Sundarbans for their livelihoods, through fishing, crabbing, and the traditional collection of wild honey from bees that nest in the forest. For carbon, the Sundarbans stores an estimated 110 to 135 tons of carbon per hectare, significantly above the average for tropical mangroves. This is a UNESCO World Heritage Site on the Indian side, since 1987, and a Ramsar site. But the Sundarbans faces serious threats. Sea level rise. Bangladesh is one of the most vulnerable countries in the world to sea level rise. The Sundarbans sits at extremely low elevation. Parts of the forest are already shrinking as sea levels rise. This is a threat that local conservation alone cannot solve. It requires global climate action. Cyclone damage. The Sundarbans protects the coast from cyclones, but major storms also damage the forest itself. Cyclone Sidr in 2007 and Cyclone Amphan in 2020 both caused significant damage to parts of the Sundarbans. Freshwater reduction. The Farakka Barrage, a dam in India, has reduced the flow of fresh water into the delta. This has increased salinity levels in parts of the Sundarbans beyond what some species can tolerate. And human pressure, encroachment, illegal logging, and overfishing by surrounding communities who depend on the forest for their livelihoods. Chapter 3. Threats to mangroves. We've just seen the threats facing the Sundarbans specifically. Now let's look at the broader picture. Globally, approximately 35% of the world's mangroves have been lost since 1980. The pace of loss has slowed in some regions, but in others it continues. The 5 main threats. Number 1, aquaculture. This is the single biggest driver of mangrove loss globally. Coastal areas are cleared to build shrimp farms and fish ponds. The irony, and you can see this is a pattern, is that many of the coastlines that lost thousands of lives in the 2004 tsunami had cleared their mangroves specifically for shrimp farming years before. Number 2, coastal development. Ports, resorts, roads, and housing all require land. In Singapore, this has been catastrophic. Over 95% of Singapore's original mangrove cover has been lost to land reclamation. Number 3, agriculture. Particularly in South and Southeast Asia, coastal mangroves have been cleared for rice paddies, coconut plantations, and palm oil. Number 4, pollution. Industrial and agricultural runoff, fertilizers, heavy metals, plastics, damages mangrove ecosystems and kills seedlings before they can establish. Number 5, sea level rise, the long-term threat. Low-lying mangrove habitats are at risk of submersion. If mangroves cannot migrate inland because human development is behind them, they are squeezed out. Let me connect threats and values in one sentence, because this connection often comes up in exam questions. Aquaculture clears mangroves. Coastal protection is removed. When the 2004 tsunami strikes, thousands die where mangroves used to be, and communities survive where mangroves remained. Development clears mangroves. Nursery grounds are destroyed. Fish catches decline. Coastal fishing communities lose their food supply and income. In both cases, the ecosystem you destroyed is the one you needed most. Chapter 4. Management strategies. What can be done? Several approaches have been used, with different levels of effectiveness. 5 strategies. Legal protection, the strongest tool available. Designating mangroves as nature reserves under national law, like Singapore's Parks and Trees Act, prohibits development within the boundary. It stops loss at the source. Replanting and restoration. Mangrove propagules are planted in degraded or cleared areas. NParks does this at Sungei Buloh. Community-based replanting projects operate in Vietnam, the Philippines, and elsewhere. International recognition. Ramsar designation and UNESCO World Heritage status bring global attention and restrict development pressure. They also attract research funding and NGO support. Sustainable aquaculture. Some coastal fish farming can be designed to coexist with mangroves. Integrated mangrove shrimp systems in Vietnam and Myanmar maintain the tree structure while still producing seafood. Community-based management. Local communities are trained to manage and benefit from mangroves sustainably, reducing the incentive to clear them for short-term gain. How effective is this management? Let's evaluate. Strengths. Legal protection is the most effective single strategy. It prevents loss at source, it is enforceable, and it costs relatively little to maintain once established. International recognition adds global accountability. Active replanting restores degraded areas and expands mangrove cover over time. Limitations. Replanting success rates vary considerably. Planted mangroves may not match the biodiversity of old-growth mangrove forest for decades, if ever. In Singapore, the 95% loss of original mangrove cover is already a fact of history. What remains is protected, but it is a fraction of what was there. Community-based management requires sustained funding and political commitment over many years, which is difficult to guarantee. And sea level rise, driven by global climate change, threatens even well-managed sites like the Sundarbans in ways that no local conservation strategy can address alone. Judgment, legal protection combined with active management is effective for what remains. But restoring what was lost will take generations. Prevention was always easier than cure. Before we finish, let's go through the 5 most common mistakes in this topic. Mistake 1, describing without explaining. Mangroves protect the coast is a description. An explanation says, the dense prop roots, trunks, and branches create resistance to water flow. Wave energy is dissipated as the wave pushes through the vegetation. Wave height is reduced by 50 to 70% per 100 meters. Mistake 2, using a case study with no mechanism and no statistic. The 2004 tsunami showed that mangroves are valuable, earns 0 marks in an explain question. The full answer names the specific place. Cuddalore, India, gives the comparison. 2 deaths with mangroves, 6,000 without, and explains why the mangrove belt reduced wave height and flow velocity. Mistake 3, overstating mangrove protection. Mangroves stop tsunamis is factually wrong. Mangroves reduce wave height and velocity. They cannot prevent the largest waves. Saying stop when you mean reduce loses marks. Mistake 4, evaluating without a judgment. If the question says evaluate, listing strengths and then weaknesses is not a complete answer. You must end with a clear judgment. Which strategy is most effective and why? Overall, legal protection is the most effective strategy because it prevents further loss. However, it cannot undo what has already been cleared. Mistake 5, using the wrong case study. You have 3 case studies. Use the right one for the right question. The 2004 tsunami is best for coastal protection. The Sundarbans is best for scale, all 4 values and threats. Sungei Buloh is best for biodiversity value and Singapore management specifically. Using Sungei Buloh to answer a question about large-scale coastal protection misses the point. Look at the quick reference table on screen. It shows you at a glance which case study to use for which question type. 2004 tsunami, best for coastal protection. Statistic, Cuddalore. 2 deaths versus 6,000 deaths from the same event. Sungei Buloh, best for biodiversity and Singapore management. Statistics, 90+ migratory bird species, 500+ animal species, Ramsar 2002. Sundarbans, best for scale, all 4 values and threats. Statistics, 10,000 square kilometers, 400 Bengal tigers, 3 to 4 million people dependent on the forest. Write these down. Case study plus statistic is what earns the 3rd mark on a 3-mark question. 5 things to take away. 1. The 4 values of mangroves: coastal protection, biodiversity, fisheries, blue carbon. For each one, you need the mechanism, not just the name. 2. Coastal protection mechanism. Prop roots, trunks, and branches resist water flow. Each 100 meters reduces wave height by 50 to 70%. 3. 2004 Tsunami. Cuddalore, India. 2 deaths with mangroves, 6,000 without. Same event, same waves. 4. Mangroves store 3 to 5 times more carbon per hectare than tropical rainforests. The reason is anaerobic soil locking organic carbon for centuries. 5. Sungei Buloh for biodiversity and Singapore management. Sundarbans for scale and all 4 values. 2004 Tsunami for the coastal protection argument. You now know why mangroves matter. 4 values, 3 case studies, a mechanism for every answer, and a statistic for every claim. 3 things to do right now. First, complete the exit ticket, 5 minutes, no notes. Second, attempt the WA practice set, 7 marks, 15 minutes. Third, self-test using the value evidence table. Cover the right-hand columns and test yourself from the value name alone. If this video helped you prepare for your exam, please like and subscribe. It helps more Sec 1 students find this channel. See you in the next one.